Okay, I wanted to go over an example of an implementation of a RESTful API using the Hapi platform, which is the JavaScript library that we're going to use for our application server. Starting out here with a simple, well, I guess I've called it a database, but that's probably too highfalutin a word for it, but I wanted to have somewhere where I could illustrate how to access a data storage mechanism from inside of the Hapi server. This is just a simple JavaScript in-memory database, and that's, again, giving it more credit than it deserves. So basically what this does is it's just a simple JavaScript class that keeps a dictionary that I'm storing in a local instance variable called users. Initially that dictionary is empty, so the constructor doesn't do anything other than just create an empty database, if you will. There's a get all users function that just returns the contents of that dictionary. There's also a get one user function that takes an identifier as the user ID and goes and tries to fish that particular user out of the dictionary by passing in the ID as the index of the dictionary. Then there's an add user that takes a user object, which is going to have an ID, a name, an email, and a phone number, and just basically duplicates that user object and stores it in the user's dictionary under user.id. So this is basically the create operation. Then I've got an update operation that updates just the phone number, just to illustrate the notion of being able to update one element in the database. So you give it the ID and the phone number, and it just stores the new phone number underneath that ID in the user's dictionary. And then finally a delete operation that takes the ID and deletes the user with that ID from the dictionary. So super simple, no error checking, no error handling, no error reporting. All it does is just gives us something that we can call from inside of our API. Okay, in the Hapi, so this is Hapi example.js. This is going to be our first example of a Hapi server, an application server that implements a RESTful API. You can see it here at the beginning that we're starting out by creating our fake little user database. So I'm just requiring that user DB file that we just looked at, and then instantiating an instance of that user DB class. If we go back here to the database file, you can see that I've defined a class user DB. So this is basically just going to run the constructor, create an empty dictionary, and assign it to the user's property of that class. So having then created this user's database, I want to add a couple of users to it. So here's Alice and her phone number and email address. And then Eva, we've talked about Alice and Bob already. Eva is also a character in that same cast of characters that's usually the hacker, because Eva is evil. Anyway, so basically just adding a couple of users to our database so we have something to query when we run some of the GET requests. Okay, so with all of those preliminaries out of the way, this is actually the business end of instantiating the Hapi server. So Hapi is a piece of software that actually initially came out of Walmart. They have a research group that they call Walmart Labs. And Hapi started out life as a project in that organization, and it actually got quite a lot of internet notoriety because it turned out to be the system that they switched over to handle all of their mobile traffic like the day before Black Friday one Thanksgiving time. And it performed so incredibly well that basically their servers saw almost no increase in load and basically handled all of their Black Friday traffic without a hiccup and without really causing the servers any problems at all. So that kind of gave it a really good reputation, and it's been going fairly strong ever since. It's kind of one of the main JavaScript node-based application servers. So, and you can follow up by clicking through this link to go see the Hapi website, and all the documentation and so forth is there. So Hapi itself, we're going to bring in here in this line of code. You can see we're using the regular require statement that we've been used to seeing to work on node applications. The name of the module that we're loading is a little bit unusual looking if you haven't seen one of these things before. In the npm.js ecosystem, they've basically allowed you to register an organization name, and the Hapi project has registered one called @Hapi. So all of the modules that they release as part of the official distribution of Hapi are going to have this @Hapi prefix, and then the application server itself is called Hapi as well. So @Hapi/Hapi. It looks a little weird, but that's the way it works. So that brings in the Hapi module into our node execution engine so that we can make use of it. Most of this file actually consists of a single function. You can see here we're defining a fat arrow function, and this is actually going to extend almost all the way down to the end of this file to right here, and then there's some error handling, and then we start up the server. So as we've seen in some other examples, a lot of what we're doing when we're using a JavaScript package like this is initializing it by providing some sort of configuration information that tells the application server how we want it to behave. So you can see that inside of this function, which we've declared to be called init, we're defining a fat arrow function, but we're also, in this particular case, we're storing that fat arrow function in this constant, which is a little unusual in the sense that a lot of the fat arrow functions that we've seen so far are intentionally written as fat arrow functions because they're anonymous. We don't really care to have a name for them or anything like that, but that's not to say that we have to use them in that fashion. So this is just another example of defining a fat arrow function that we're going to then store in a constant so that we can invoke it later. And if we skip back down to the end of this file, we'll see that here in the last statement, we're going to actually call init. So init, and then there's the open close parens that makes it a function invocation. So we're going to run this function that we're defining up here later on in the file. Notice that the fat arrow function has a curly brace body, obviously, because there's quite a lot of complex stuff going on the right-hand side. And on the left-hand side, it is got an empty argument list. So there's no arguments we need to pass in. There's no arguments we can pass in. So when we invoke it down at the end of this file, you can see that it's being invoked with an empty parameter list. Go back up here. We can see that because we're going to do network operations, handling requests from our web browser and so forth, we want to have this be an asynchronous function because we want to do things asynchronously. So we're going to use the async await pattern for running asynchronous functions. And as you can see in here, there's several instances of await. That means because we've got these awaits inside the function, you remember that means we just have to tell JavaScript, hey, this function is going to have asynchronous behavior. It's going to have awaits inside of it, so we have to declare it to be async itself. Okay, so what are we doing inside of this init function? So first of all, we're going to actually create an instance of the Hapi server. So we brought in this object called Hapi, and it defines a method called server that allows us to configure an application server. So Hapi of server, and as we've seen already with some of these other JavaScript packages, and as I just mentioned, we're going to pass this guy a configuration object that's going to specify a host name and a port number. So the host name is just going to be my local PC, and then the port number is going to be the port on which Hapi is going to listen. And when we want to connect to it, we want to be sure to specify that port number, and we'll see that in a second. We also want to configure some other modules that work with Hapi. They have, as you'll find out, Hapi and the Hapi ecosystem have relatively weird names for things. I think Hapi itself comes from the Ren and Stimpy cartoons where it's happy, happy, joy, joy. We'll see that joy is actually a validation library that's used commonly with Hapi. But there's other weird names in the ecosystem that that you kind of have to get used to. One of these things is called blip. So we're requiring this package called blip, and we're registering it with the server. So there's the server that we've created. We're going to register these plugin objects that add functionality to the basic Hapi server. We'll see that blip is going to show us the list of routes that are configured inside of this server. And I'll show you what that looks like in a minute. And then we're also going to configure another plugin by registering this other module with the server. And it's a module called Hapi Pino. And this is going to be a logging plugin that allows us to see kind of the details of what's taking place in the requests and the responses that we're going to be sending to Hapi and getting responses back from. So that's all just kind of boilerplate code. Create the server, output the information in the configuration, do some logging, and kind of copy and paste and forget that stuff. It's not really the interesting part of the configuration. The interesting part comes here in the next main chunk of this init function. And I've got a comment here that says define routes. So what the Hapi server refers to as routes are basically the URLs on which the server is going to listen for requests from the client. So if you think about this in the sense of the RESTful API information that we learned about previously, when we talk about the URL that's going to be used to operate on a resource, what we're using as the URL is going to be, in Hapi's terminology, a route. We're going to define this route that corresponds to the URLs that we've defined in our RESTful API. So in this route function, what we are going to pass here is an array of objects. So the beginning of the argument to this route function is this open square bracket. And if we scooch all the way down here near to the end, we'll find that closing square bracket. So all these objects that you see in here, kind of nicely formatted, are inside of this top level array. So we can configure a route at a time if we want to do that. We can say server.route and then give it just one piece of route information, or more commonly, we're going to say server.route and give it an array of route configuration objects to specify multiple routes in one go. Okay, so let's take a look at one of these route objects. So this object is a configuration of a single route. We're basically telling Hapi, hey, listen for URLs of this shape, and when you see one like this, then run some code. So first of all, we have to tell the route what HTTP method we want to have it respond to, right? When we were talking about the RESTful APIs, we saw that each of the RESTful APIs could have multiple different methods that could apply to the same URL. So it'd be possible for us to have multiple methods associated with each of the routes in this file. And we'll see that because we want each of those different methods to invoke different code, maybe even for a repeat of the same URL, we're going to break those out into separate configuration objects in this file. So the first one here basically says we want to respond to a GET request. Okay, so that would be the method that we're going to be sending. But what does the URL look like? Well, the path argument here tells Hapi to listen, in this case, for just the slash is an indication to listen for just the default route. So if we don't have anything else in the URL other than just the slash after the host name, this is the route that's going to match on a GET request. And then the handler is the third important parameter here that we pass into each of these route objects. And this guy is basically saying, here's the function I want you to run when you receive a GET request to the default route. And you can see that the value of this handler function is a fat arrow function. So that's what I mean when I say this is the code that I want you to run when you receive a GET request to the default route. And you can see that this function itself is very, very simple. It's basically just returning a string. And we'll see how Hapi handles that in a second. Now, okay, first thing to do here is to start the Hapi server running. In this case, and we'll look at some more sophisticated ways of keeping servers running and whatnot in the future. But this isn't a node program, so I'm just going to say node, and then the name of the top level Hapi application server code is hapiexample.js. And let me make this window a little bigger. You can see when the thing starts up, it gives us some information about what URL it's listening on. Remember that when we back up here, when we set up our server object, we said, I want you to listen on the local host, that is my laptop, on port 3000. And you can see here that it's telling us it's listening at HTTP localhost :3000. So this is basically the host and port number on which Hapi is going to listen. So all of the URL endpoints that correspond to our RESTful API that we're building are going to be relative to that URL. In this next section here, I mentioned before that this blip module up here is going to output a list of all of the endpoints when the application engine starts up. And that's what we're seeing here. Basically, the blip plugin looks at the routes that have been configured into the Hapi server object, and it just prints them out in a nice format. So you can see here it tells us that there's different methods that it's going to respond to, and then the path is basically the URL segment after this common localhost 3000 piece. And then there's different paths that it can respond to. So it can respond to a GET request to the default, a GET request to a list of users, a POST request to a list of users, and so forth. A GET request for a specific user that has an ID, and so forth. And we'll unpack how these things work in a second. But that just kind of gives you a little index or a dictionary or a table of contents for what information the Hapi application server is going to be, the service that it's going to actually be able to provide. And then up here we also had created this logging object, Hapi Pino, and this is the output that's coming from that. It's basically going to be used by the server to just give us information about what it's doing behind the scenes. And this is kind of just for your benefit to sort of see what's taking place under the hood a little bit. You can see that it gives us some timestamps, and it tells us what host it's listening on and what protocol and that kind of stuff. And as well as the URL. Well, in this case, it says it's a URI, right? And we know what that means now. That it's going to be listening on this URI for requests. Now, I could click through this URL or URI, and it'll open up my browser, and you can see, well, what is the browser saying? So here's the URL in the browser address window, and it's showing us that the contents of this endpoint is just the string Hapi rocks. And although that's what's going to be that's what's being displayed in the browser, if we look at the source window, we can see that the same thing is in the source, right? All we got back from the server was this string Hapi rocks. So that's not super interesting yet, but we are in fact making a connection to the RESTful API. We sent a request, a GET request, right? Because that's what you will send by default when you just click through a link. We sent a GET request to the default route because we didn't give it any additional stuff after the localhost 3000. And what happened was Hapi saw that request coming in, and it looked through its list of configured routes, and it matched this one, the one that we just discussed. It's a GET request to the default route, and the handler function that gets run is returning this string Hapi rocks. And that's exactly what we see here in our browser. Okay. And then there's some additional information here that tells us a lot more detail about what actually took place. So this is, again, output from that logging module, Hapi Pino, that is giving us some details about the request that was received. You can see that it was a GET method to this URL. There's a bunch of headers that get sent along with the request. In this case, there was a cookie. There's my Jupyter Hub session cookie for some reason, because I also run Jupyter on this local machine. We also get information about the response. So we've got basically two objects here, a request object that has all the information that got sent to the server, and then a response object that was generated by Hapi. And you can see that it sends back, for example, a status code of 200. And we know from previous web experience that an HTTP status code of 200 or anything in the 200s range indicates a successful query. Whereas something like a 404, something in the 400 range, means that there was some kind of a problem with the request. So there's always a status code that's returned by an HTTP request, and then there's some additional headers, and then of course we know that the content of the reply was just this string Hapi rocks. Now, it's fine to be able to send these kind of simple GET requests using a browser, but we want to actually be able to try exercising other parts of the API that are going to be a little bit more difficult to do from inside the browser. We don't want to have to build up a web form or write some kind of JavaScript to do that quite yet. So I want to introduce you to another tool that makes it easier for us to query a web-based API. This is something called Postman. There's its logo. You can download it for free. It's an open source package that's, I think, actually written in JavaScript or TypeScript and is available cross-platform. But its main function is to be able to send arbitrary HTTP requests, retrieve responses, and let you debug APIs. So I've already defined some requests here. You can see that here inside of my 243 folder, I've got another folder called Hapi Intro. And just kind of inspecting these routes, you can see that there's get requests, there's a post request, there's a patch request, there's a delete request. All of those things you can configure really quite easily inside of Postman instead of trying to have to write a bunch of code or manipulate your browser to do these sorts of things. So it's a super easy tool for exercising and testing an API. So let's just look at this one I've called default route. You can see here in this tab, it's going to use the get method. If I drop this down, you can see that it will allow you to send other types of HTTP requests, even more than we talked about so far in the discussion of the RESTful API. We're going to stick with get. And we're going to send this get request to localhost:3000/, right, the default route. And then when I push the send button, it's going to, Postman is now kind of standing in instead of my browser. It's the client program that's going to send a request to the Hapi server that's still running over here inside my IDE. So I'm going to push the send button, and you can see that the response that comes back from that is also displayed here inside of Postman. And as you won't be surprised to see, it's got the same message that we saw in our browser. Okay, so far, who cares? Why did we need to use Postman? Well, we're going to start to see why this might matter here in a second. Okay, let's go back to the source code for the Hapi API configuration. We can see here that we've kind of exhausted this first route, this first endpoint. We'll look at the second one. This is also a GET request. It's now going to be sending a request with the URL /users instead of just the default route. And that should start to remind you of a collection style URL from when we talked about the RESTful APIs. So when the client sends a GET request to /users, it's going to tell Hapi to run this particular code. And now inside of this handler function, we're going to actually use this fakey little users database that I created up above, right? Recall that that's this thing up here. I defined this instance of that user database called users. I added a couple users to it just to kind of give us some data to look at. And now what you'll see is when this request is received, Hapi is going to run this function, users.getAllUsers. And we know that this function is going to give us back, so that I just navigated back to my userdb source code. This getAllUsers function is just going to return the current contents of this users object inside my fake little database. So let's go and execute this particular query. So I've already set this up, another GET request, so I'll click that, and now you can see we've got, I guess I didn't save this properly the last time I did this. I've got a users command. It's a GET request. It's sending a GET request to localhost 3000, but I want to send it to 3000/users. Oops, users. And then when I hit send, it should hit this endpoint in the Hapi server. And there we go. So you can see what happened here is that Hapi received a request from the client. The request was a GET request. It was to the /users endpoint within this same URL that we configured before. And when it received that request, it looks for the function that's listed in the handler property, and it runs the code that it finds there. In this case, it invokes the getAllUsers method of that users class, which is going to give us back, if I can switch back over to my database code again, all of the users that are currently in the database. In this case, we had kind of preceded our user database, our little in-memory database with these two users, Alice and Eva. And if we go here to the result of the query, we can see there's Alice's information and there's Eva's information. It's nicely formatted and stuff. The formatting is actually being done for us by the Postman client here. If we want to look at the raw response information, we can see that as well. That's what actually was sent by Hapi after fetching that information out of our little user database. And then Postman, recognizing that this was a JSON thing, formatted it for us nicely. Okay, so that's kind of our first interesting query that we're posting to, or that we're sending to our server. Okay, so that's these first two routes. So that GET request, again, this was to the entire collection of users, right? We just said, give me all the users that are in the database currently. But we also might want to request information about a specific user. So if you think back to the RESTful API discussion, when we want to talk to a specific element of a collection, we normally give the name of the collection, and then we follow that up with an identifier that refers to a specific element of the collection. And this syntax here with the curly braces around the ID, that's a Hapi specific way of allowing you to parameterize a route endpoint. We're basically saying we're going to have a get, we want to respond to a GET request that goes to the user's endpoint that includes after that in the next segment of the URL an ID value. And you can see if we go back to this output from Blip, we can see that we have this GET request to users and then curly brace surrounding ID. And what that's telling Hapi is to expect a GET request to the user's endpoint where there's something following the user information there. The examples in the handout for the RESTful API talk use numeric values there. We're actually going to use string values, and Hapi's perfectly fine with that. So we're saying we're treating this ID inside the curly braces as kind of a placeholder to say, hey, when you get this request, there's going to be some specific actual value that's going to be supplied there. Fish that out of the URL and let us use that to access the database. So here in the server code, there's our endpoint with the placeholder value here. It turns out that, well, and we've seen this already, but we haven't made use of it. The handler function, it takes two arguments or two parameters, a request parameter and this other thing called H, which is short for Hapi. And we're going to kind of ignore H for now, but request is actually a lot of information about the request that Hapi has received. So Hapi itself is busy listening on localhost port 3000 for inbound requests from a client. When it gets that request, it's going to look up in the list of routes to find the matching route, and it's going to also take a lot of information from the network connection, from the server information that gets sent over in headers, as well as the URL itself, and it's going to unpack some of that information and give us access to that through this request parameter. So Hapi is calling us, it's calling this handler function, and it's giving us all the information about the inbound request in this first parameter. One of the things that's in that request object is a list of parameters, which is basically Hapi's terminology for these kinds of placeholders that can be sent in as part of the URL. So the request.params is referring to a dictionary, an object in JavaScript that will have values in it that correspond to this ID placeholder. And you can see we're just accessing request.params.id. Now, we could have called this anything. I could have called that Fred, in which case I would look for request.params.fred. That, whatever I call that there, is going to be replaced with the actual contents of the URL. And let me show you what I mean here. If we go back and look at our database, we can see that the values that I've used for IDs here are not numeric values. They're actually just strings, Alice and Eva in all lowercase. And when I fetch, if I go back to the database code here, when I want to get a particular user, I want to look them up by ID. And I'm just going to use that exact ID value as the key into this users dictionary. That's really the main storage for all of my things in my little database here. So eventually when I go out to the database to get this user, I want to grab whatever it is that user ID has, which is what came in the URL. So in the case of, let's say I want to fetch Alice here. So I'll open this up. You can see that the URL to get Alice is /users/Alice. So instead of just saying /users, which gave me all the 2 users I have in my database, if I want to get just Alice, here I'm giving this additional section of the URL that's going to be interpreted as the ID by which I'm going to look up Alice's record. So if I send this request, we'll see that we just get Alice back now. So what happened is the users/Alice was sent to the server. The matching route that Hapi found for us was /users/something, and it was a GET request. If I go back here, you can see this was still a GET request. So the /users/something, this is the route that matched. And the /something is going to be referred to inside this code by this identifier, by ID. So request.params.id in this case is going to be the string, is going to be this string Alice. So this line of code right here, line 68, is going to get from the request, fish out the params, and grab the one called ID, which is going to have as its value Alice, and that's going to get stored in this variable or this constant. We'll come back to this logger line, but then using that information, I'm going to call this getOneUser function with that ID. So this is going to pass the string Alice to getOneUser. GetOneUser is going to look up, so this is going to be Alice, and it's going to look for this.users of Alice, and that's going to fish Alice's information out of our little fake database. And that's where, and then it sends that result back to us in the client. I wanted to show you this, this logging output. You can see here, put one of the output lines in the logger has the details that I've put into the route handler. This is a really simple way of trying to do debugging inside the route handler. It's kind of not necessary in this case. It's quite simple, but as your route handler functions get more elaborate, it can be helpful to have some output. So the request object includes a link to this logger object. Where did that come from? Well, if we go back up here to the beginning of this file where we configured these plugins, we created a plugin, or we added a plugin called Hapi Pino. This is the logger object, and it's defined. If you go look at the documentation for Hapi Pino, you'll see that it attaches itself as the logger object to your requests in your Hapi server. So by using request.logger, we get access to that logging plugin. It's got a method called info that prints an info message. And then here's the string that it's going to print, request for details of user. And then I'm using a template literal with the curly brace substitution of the user ID that I fished out of the URL. And then that gets printed here, request for details of user Alice. And then we return the particular user. Now notice that there's some magic going on here. It's good magic and it's pretty simple. So in the case of this first request that we looked at to the default route, go back to look at the default route. Remember that when we send that request, we just get a string, Hapi rocks. But when we send a request to get all the users, we get back a JavaScript, we get back a JSON string. In the case of the default route handler, you can see that what we're returning back to Hapi is just an ordinary string. Whereas when we get all the users, well, this thing, this function, if we go through to its definition, this function actually returns this.users, which is an object. It's a JavaScript object, which is not the same thing, obviously, as a JavaScript string. What Hapi does is it sort of helps us return the right kind of thing back to our client, depending on what we return from these route handler functions. So when we return a string, Hapi basically does nothing other than send that string back as is. So when we saw the return value from this default route, we just see that string of characters Hapi rocks with no other information. However, when we return from a route handler function with an object, Hapi assumes that we intend for that to be sent back to the client as a JSON string. So it will automatically encode this return value, this object, as JSON. Remember that the object is something that lives in memory, whereas the JSON is a string representation of that object that we can send over the network. So in the case of the get users, and again, let me go back to this raw form of the response. This is actually the information that Hapi sent back to us, and then the pretty tab interprets it nicely as a JSON object. But that's being done for us by Postman. The raw content is this JSON string. And you can see this is actually a string that's got a bunch of quotes and all sorts of things. This is not an object, right? It's a string that represents an object, which is exactly what JSON is. And because most of our communication in a RESTful API these days is going to be using JSON objects, Hapi is designed in such a way that it will send that information in the proper format for us. We don't have to do any other function calls or say, hey, encode this as a JSON string and send it across the wire. We just return an object and Hapi takes care of it for us. And the same thing is true for the get all users and the get one user endpoint that we've looked at so far. So if I go back to this get one user getting Alice and I hit send again, and look at the raw output, that's the JSON string that Hapi sent back to us. And then the Postman program, it allows us to ask it to lay that stuff out in a nice format. Oh, I was going to also show you that we can, if we want to get Eva's information, we can just say Eva. And it uses, now that value, Eva, is going to be what's fished out of the URL as this ID placeholder. Eva will be stored in this user ID. We should see Eva in this output, and we get the value for Eva back from our little database as an object, and we send it back to the client where it's encoded by Hapi as a JSON string. If we give it something bogus, well, now we got a problem. It turns out that, so if we think about what happened here, the Postman was perfectly happy to send something bogus as the value for this portion of the URL. So something dash bogus got stored here. And then when we called the get one user function with something dash bogus, we tried to look up in the user's object something that didn't exist, which would have thrown an error. Happy catches those errors and turns them into a meaningful JSON object that says, hey, we had a server error problem. So instead of getting a nice 200 response with the actual data, we actually got a 500 response, which is, and the 500 series of errors corresponds to things where there's a problem on the server, which is exactly what happened here. We sent a request. We didn't do any kind of error checking. We just stumbled forward and tried to look up a bogus key inside of a dictionary, and that raised an error, and Hapi caught the error and sent back to the client this error code. Okay. So that takes care of, I'm going to go back to the list of routes that we've been working through. So we've talked about getting the default, getting all of the users, getting a specific user by ID. Now we're going to talk about posting a user. And you'll remember from our discussion of RESTful APIs that the post request or the post method corresponds to the create element of the CRUD pattern. I want to create a new user in this case. So here's in the source code, here's the post request to the user's endpoint. And notice that, as we've been saying, we can send different requests to the same endpoint to ask the server to do different things. So you'll see here for this handler, we're using /users/, and for this handler, we're using /users/. The difference is that this is a GET request and this is a POST request. So this one is being interpreted by our code as retrieving all the users, and this one's going to be interpreted by our code as creating a new user. Well, so we've got the POST to the user's endpoint. We've got our request information coming in, and here's what we're going to actually call inside of our little mini database. So if I click through to add user, you'll recall that this gets a user object, and it basically just makes a duplicate of that user object, and it stores it in the user's object that we defined up here under the key corresponding to whatever the ID was. So what you can see from this invocation of that method is that we're passing to that add user method something that's coming out of the payload, out of the request. So it turns out that that's going to have to be a JSON it's going to be encoded as a JSON object containing the information for the new user that we want to add. Now, if we had a bona fide application or a bona fide web application running inside of our browser, we would have had a form posted for the user that would have allowed them to type in their name and phone number and email and stuff. And then when the user pushed the submit button, it would have packaged that all up as a JSON object and sent it across the wire to this endpoint, at which point Hapi would have unpacked that information and then handed it into the add user function. You can see that whereas in this request, where we wanted to get a parameter out of the URL, we used request.params to fish that out. Here's another property on that request object is called Payload, and the payload is the actual contents of the message that was sent from the client. In the case of a browser running a web application, that's going to be a JSON object that's then going to be used in this case to add a new user. For our test case, we're going to add Bob to our database. So let me open up this request. So here's Bob. We're going to send a POST request to localhost 3000 to the same URL as we were doing to get all the users, except now we're going to create one. And we've got to also supply some information to say, here's the user we want to create. Well, in Postman, the way you do that is you give a JSON object as the body of the request, right? So here's all Bob's information formatted nicely as a JSON or as JSON object. You can send all sorts of different kinds of things inside of Postman. So you can send forms or URL encoded stuff or binary data or send GraphQL queries. We're just going to choose raw here, and then we can pretty much type in any kind of data we want here that's going to be transmitted across the wire. But you can choose some specific formats, and because we're intending to send a JSON object, if we choose JSON here, it gives us some nice syntax highlighting, and it'll give us an indication that there's something wrong, like if we skip a comma or something like that. So I had to type this in manually in this case, and as I said before, this would normally come from the contents of a form in our web app, but I just typed this in manually as the body to be sent to Hapi with this request. So let's go ahead and send this. Push the send button. It's going to send a POST request to our server. If we go down here in our logging output, we'll see here down at the end we got we got a request to this user's URL. It was a POST method, and it had content associated with it that was retrieved out of the request by using this payload property, and that corresponds basically to the contents of the JSON that we passed to it. Now you recall that when we want to call this add user function, we want to pass it a user object. This thing in our request was actually sent over the wire as a string, but this is another place where Hapi helps us out. When it sees a request that has a payload that looks like JSON, Hapi will turn that into an actual JavaScript object. So the payload here has already been automatically decoded by Hapi from a JSON string into a bona fide JavaScript object. So it's doing exactly the converse operation or the inverse operation of what takes place when we return an object from a handler. It takes the object and turns it into JSON for transmission back to the client. And on an inbound request that contains JSON, it takes the JSON string and converts it into an object so that when we access it through the payload property of the request, it's already an object, which is what add user expects, so it can just go ahead and add it to our little mini database right away. Now, it's a little less clear what we want to return when we're handling a post request. When you are talking to a database, for example, a SQL database, and you do an insert statement to add something to a table, the database basically just comes back with a number that says, here's how many rows were affected in the table. We could certainly send back the number 1 here to say, yeah, we added one row to not one row, but one object to our little miniature database. But that's not really required necessarily by the notion of a RESTful API. So I've chosen to do something else here, where after I add the user, I go ahead and just fetch it back right away. So I go to the request payload and get the ID out of the payload. Notice that I'm referring to the payload again. That's the object that came in the request. So here's Bob's request. You can see that his ID was Bob, but the point here is that there is an ID property of the payload, and that's what I'm fishing out here and passing it to the getOneUser method of the user's database, which is the same thing we did here in the get request. So I'm just fishing the value back out of the database and returning it. And that explains why I get Bob back here in his entirety as the result of that request. Now we could, since we've now added something to our little in-memory database, let's go back and query for all of our users. Before we just had Alice and Eva, but now when I send this request, we should see Alice and Eva, and there's Bob. So he's been added to our list of users. We can also go and ask specifically for Bob's information. Let's improve on this something bogus and ask for Bob, and there's Bob. Okay. Now, let's look at another type of endpoint. Remember that when we want to do the update part of the CRUD pattern, we have two alternatives. One method is called put, which is intended to basically replace an existing resource in its entirety. And the other is called patch, which is intended to make a smaller change to an existing entity. So that's what we're going to do here. This is basically going to, remember I defined this function here in my database called update phone. It's awfully specific, but it serves our purposes here. And it's just going to update the phone for a user with the given ID. So now with this patch request, I've got to do sort of two jobs. I've got to say which user do I want to patch, and I'm going to do that the same way that I did when I was asking for details about a user in the get request up here. I said which user do I want to get. Now I'm saying which user do I want to patch. So I'm going to pass the ID of that user in the URL, but I've also got to be able to supply information to Hapi to say what data do I want to update in that user's record. So that's quite similar to what I had to pass in the post request, except in the post request I sent all the information for that user. Here I just want to send the phone number for that user. So in a way, you can see these patch and put requests as kind of a combination of two things, right? It's sort of like a get in that we've got to tell it which thing we want to patch. It's sort of like a post in that we have to send it the information we want to have updated in that particular user. So I'm going to use the ID parameter here, but I'm also going to arrange to send a payload that's going to include the new phone number. So my handler function for the patch request, I'm going to call this update phone function that we just looked at in the little database code. And let's just go there. You recall that we need to pass the ID and the new phone number into this function. Well, the ID is going to come in as part of the URL. So just like up here where I'm doing a get, I want to say request.params.id. And notice that it's params here because I'm fishing things out of the URL. But I also want to get the phone number, which came across in the payload of the message. So I'm going to say request.payload.phone to get the phone out of the request. Let's go look at how that works here on the server side. We're going to actually update on the client side, we're going to update Bob's phone number. So I'm going to send a patch request to localhost 3000 users/Bob. So that's what's going to be filling in the blank where the ID placeholder is in the patch request handler. But I'm also going to include some body information. So I've decided to make these just consistently use JSON. So although all I would really have to send is the string containing the updated phone number, I'm going to send an actual JSON object, because it'd be certainly possible to write a patch request handler that handled patching of multiple values, and then it'd be easy to encode those in the JSON object. So I'm making a JSON object here that says phone and then the name of and then the new phone number. So this key is going to be what's used to grab that value out of the payload in the route handler to be able to pass that information into the update phone method. Okay. Just to remind us one more time here, let's go. So we're going to get Bob's information, and let's just verify. Okay, Bob's got an 800 number right now. And then we're going to do a post request. We're going to do a patch request to update Bob's phone number to an upland number. So I'm going to say send. And now here is Bob's new record. You'll notice that back here in the server code, I did the same thing as I did after the post request. I just went and fetched Bob's information all over again from the database. And you can see that Bob now has this 765 phone number. We can verify that if we're still doubtful by going back and asking for Bob's information here. And now we should be able to see a change from this old value that I just looked up to its current value, which has his new phone number. And if we go to get all the users, Bob's old phone number is still here from before, an 800 number. When I hit send again, everything's the same except Bob's phone number is now an upland number. Okay, then finally we have a delete request. So this kind of completes our CRUD pattern, right? We had a get of all the users, a get of one user. That would be the retrieve part of CRUD. We've got a post request to create a new user. That would be the create part of CRUD. We've got a patch request, which is the update, the U part of CRUD. And now here's the D, the delete part of CRUD. So when we delete a user, we're typically going to want to delete a single user, not all of our users. So this is very, very likely to be an element style API request. So we got to send the users collection and then the ID of the particular user we want to get rid of. Then in our handler function, I'm going to do a couple of things here. Well, one is I'm going to fetch the user's information out of the database. I wouldn't strictly have to do this in this case, but I guess from the perspective of maybe just doing a little bit of error checking, I'm not really checking, but this will raise an error if I can't find that particular user. So I grab the ID out of the params. Again, params gives us stuff from the URL, whereas payload gave us stuff from the payload. So params.id is going to give me whatever the actual value is for this placeholder. And I'm going to go get that user out of the database, and that's going to store the user object here. Then I'm going to go ahead and delete that user, sending in the same request.params.id to the delete user function. And if I click through that, you'll recall this just does an ordinary JavaScript delete. So that'll delete the user. And here's why I went to the trouble of fetching the user first. The way I've designed this is that I'm going to send back to the client the value of the user or the content of the user that I just deleted. Now, I don't know if that would be useful or not. It's just what I chose to do in this implementation. Again, it's actually pretty common at the level of the database, sort of way down on the server side stack, to instead of giving back the object itself or the row in the database, to just give back a count that basically says, here's how many rows were affected. The same thing is usually true when you do a delete operation in SQL. It just tells you how many rows were deleted. I'm doing something a little bit more elaborate here, and I had to fetch the existing user out of the database first so that I had all of the data to send back. Then I went in and deleted it and then returned the actual user data. And because this was an object coming back from our little mini database, when I return that object, Hapi converts it into a JSON response. So let's go here to my delete example, and we're going to get rid of Eva the evil. So here it's a delete request. It's going to users/Eva. And if we hit send here, we should get, well, okay, there's Eva's data that was in the system, but should no longer be there. So if we go back to our get request for all the users and run it again, we should see only Alice and Bob remain in our database. Eva's gone. Okay, so that concludes our discussion of all of these route endpoints, which is really the business end of this application server. Just a couple of other things that are necessary here to make this work properly. You remember that we're inside of this function called init. We can actually collapse that down and you kind of see the structure of the code. So here's where we created the Hapi server object, and then this init function is got all that configuration stuff inside of it. And you remember that because we're doing asynchronous things inside of here, we're running the await function, we have to define this thing to be asynchronous, which means that we can't just have this be top-level code, right? We can't have an await function at the top level. That's another reason that we wrap this up in a function. Once we've defined that, we can then call it. And that's what happens here at the end of the code. We just run that function. Now, if we go back in, but that doesn't start anything up on the Hapi server, actually. It just calls this function and does all that configuration. The Hapi server itself actually gets started here at the end of this init function. Go all the way down here, we can see server.start. So this is that server object that we've been configuring all along, right? When we say server.route or server.register and so forth, we've by this line of code, we've got it all configured and we just need to let it run. So we say server.start. Well, that's an asynchronous function, right? Because it's going out and listening to network requests and so forth. So this has to actually be awaited, which is another reason that we have to wrap this whole thing up in an init function that is defined to be asynchronous. Then finally, once that's all defined, we can come back out here to our top level code and run that initialization function, which will configure and execute the server. This other thing here is basically just a little placeholder that allows us to handle any bogus problems that bubble up out of Hapi. And I've included some information here that just basically says if a promise is rejected and there isn't an error handler attached to it, then run this code. So this is kind of like a sort of a catch clause on steroids that's going to be invoked by Node if something goes haywire. So it's just kind of there to catch any really goofy behaviors, but most of the error handling should be taken care of by our code up here. And I'm fully aware that this is a super simple implementation of these endpoints. There's essentially no error handling taking place. That's never something that you want to do in production code, but for purposes of illustrating how this thing works, I elected to leave all that stuff out. So that is a brief introduction to how Hapi works, how we configure it, how we set up different plugins that we might want to use with it. And the really important part is this section on the route handlers. We define these routes with the HTTP method we want to respond to, the URL path that we want to have trigger that response, and then the handler function is what actually goes out and generates the response that's sent back to the browser. In our case, of course, we're using Postman instead of the browser. And this is still a tool that I use all the time with app development because it just makes it super easy to test an endpoint in isolation. If I've got a problem that I'm trying to diagnose, one of the first things I'll often do is just make sure that I'm sending and receiving the right information from the server before I go and try to diagnose anything inside of my application code on the browser side. It just complicates matters if you're trying to debug both the network requests over here and the application code in the browser. So kind of separate those things apart And I continue to use Postman as sort of my go-to tool to verify that the server is sending me back what I think it's sending me. And then once I know that that's working the way I expect it to, I can use that information to go ahead and figure out what's going on in the application code itself.